Okay, let's take a walk through some of the unique properties. The first one is called hydrogen bonding. There are hydrogen bonds that form between polar water molecules to satisfy the polarity on either side. When you have a liquid water with so many molecules close to each other, two molecules can attach to each other and satisfy this polarity. So you have a positive polarity on the hydrogen side and the negative polarity on the oxygen side, so they can attach to each other with this so-called hydrogen bond, and this attraction gives it a strength that is not easy to break. So a lot of the properties of water end up relating to how the molecules are held together because of this hydrogen bond. So this is something very unique that you'll have to remember. Hydrogen bonds actually are weaker than covalent bonds, where the hydrogen is attaching itself to oxygen by sharing an electron. That's a very strong bond. That's not very easy to break. But these hydrogen bonds, while they are strong, they are not as strong as the covalent bonds, but they give water a so-called cohesion, or a property of sticking together. So if you take a glass and start filling water and very carefully keep pouring, you can easily make the water rise a little bit above the surface of the top of the glass, because the molecules can hold together and form, because of the surface tension, they can form water to rise slightly above. You can do that experiment at home. So the high surface tension is a property that's very useful in many aspects of how the water is used by various life forms, and we will see some examples of that. It also makes water a very good solvent. It dissolves many chemical compounds, and we'll see why something like oil doesn't dissolve in water, even though water is a universal solvent. And it gives very unusual thermal properties for water. For a substance like water, with its mass and molecular weight and so on, it should have certain freezing point, a certain melting point, and so on, but water has very different values because of these hydrogen properties, and it has very unusual density as well as we cool it or warm it. And water is a solvent. What does that mean? So this dipolar or polarity it has, if you take something like table salt, which is NaCl, again, remember sodium is a metal, very reactive metal, and chlorine is a very toxic gas. But if you bring them together, you form NaCl, which is just common salt, which is also such a critical element for life, and it's such a big part of ocean water. Right? Ocean water is very salty. So water polarity is again able to easily split the NaCl, where Na, sodium, has a positive charge, and Cl, which has a negative charge. So their covalent bond is broken by water, and Cl attaches to the hydrogen side, which has a positive charge, and Na, which has a positive charge, attaches to Cl attaches to the hydrogen, which has a positive charge, and Na plus attaches to the oxygen side, which has a negative charge. This is how most substances that dissolve in water get split, because of the polarity of the water molecule. The thermal properties of water is worth looking at in detail, so I'll do it in another podcast. Water is in solid form, liquid form, and gas form at Earth's surface, and it heavily influences Earth's heat budget. Heat budget means what? Essentially, as the energy is received from the sun, the energy is stored, temperature of the ocean surface, land surface, and so on are changed, and that heat is stored and released. So as the temperature changes, the amount of heat in the ocean or on land or in ice changes, and it is that movement of the heat that we call heat budget. So I will start this water properties next podcast, but let's quickly look at the three states of matter. When the molecules are well arranged and into these shapes shown on the left, you have solid ice. And when you add energy to ice, you melt it and make it liquid water, where the molecules are still bound together by hydrogen bonds, but they are moving quite freely. If you add more energy, you can make the water boil, and if you keep adding more energy, you can create water to vaporize, in which case the water vapor is in a gaseous state. Then the molecules are not interacting much with each other, and they are not bound together anymore by these hydrogen bonds. If you go in the other direction and condense water vapor, then you will end up again forming liquid water. And if you take energy out of the liquid water and freeze it, you'll go back to solid ice, where the molecules get arranged again. And the magical thing that happens here is that because you arranged the molecules in this structure, the density of the ice actually ends up being less than liquid water. The only substance where, when you actually freeze it, its density actually decreases. This is what makes ice float on water, and this has many consequences, as we know. So let's stop this podcast here and follow it up with more properties in the next